Okay, let us discuss this problem. So this is a quite easy problem. So this says we have a loop. So ABCD is a rectangular loop we have been given, and this loop is made up of a wire, and there are two resistors R1 and R2 that is connected in this loop. There is a connector that is also connected, and this connector has a resistance R, and this connector moves with velocity v that is given to you. And question says there are no mutual or self-inductance, so neglect the self-inductance. So this means L is equals to 0 that is given to you, and we have to find what is the current through this connector. So this is the current. So you see, if we are moving this one, there is an induced EMF through this connector. Everybody knows this induced EMF is BLV. So if you know the induced EMF, basically you can calculate what is the current through this connector. So what is my task? My task is to calculate current through the connector. Are you getting it? So we have to calculate current through connector. So how will you proceed for this part? Now we have to calculate current through the connector. Let me first make the electrical circuit for this system. Now this system, if it's moving something like this way, there is induced EMF BLV. I know the connector length is L, and magnetic field inside there is a magnetic field. So in this whole region we have a magnetic field. So I know the B, so I know the BLV. This is the induced EMF. So if I write this circuit as equivalent electrical circuit, it will look something like this. So it will have, let us say, I can write here. So it will have a resistance this side, and another resistance you will have this side. Are you getting or not? So this is another resistance you will have this side, and there is an induced EMF. So let us say you have a battery kind of thing here, and then this has an internal resistance R. So this resistance is R1, this resistance is R2, and this resistance is R, and this battery has an EMF Xi. What will the value of Xi? Xi is nothing but BLV. Are you getting or not? Now we have to solve this circuit. It's easy. If you see this one and this one, these two resistors are connected in parallel. So R1, R2 are connected in parallel. Now can you understand this one or not? So you see, and this will act as internal resistance. So system is very easy. If I want to find equivalent resistance of this system, what is the equivalent resistance? These two are in parallel, and then this is in series. Are you getting or not? Let me show you again. So R1, R2, that is in parallel. I am not finding, and then so this is in parallel, and then you have R that is in series. So this whole thing is in series. Are you getting or not? So if I try to write the equivalent system, let me write two again diagrams. So you will have one EMF resistance is R, and their equivalent resistance you will have R1, R2 that is in parallel. So I know the parallel resistance equivalent is R1, R2 divided by R1 plus R2, and then you have R that is in series. So finally I will have, so this system can be reduced into this system. So this system can be reduced into this system, and this becomes R equivalent, and this is nothing but R plus R1, R2 divided by R1 plus R2. Are you getting or not? So if you know R equivalent and this Xi is basically VLV, so you can calculate current through this circuit. So what is the current? So let me now do the mathematics. So what will the current? So current will be Xi by R equivalent, that is the current, total current through the circuit. So this means Xi is BLV, so current is BLV, and this divided by R equivalent. Are you getting or not? And R equivalent is given by this formula. Now we have to find what is the current through the connector. So whatever the current that is coming here, this current, whatever the current the battery gives, this current, when it divided into two parts, I1 and I2, let us say this side you have a current I1 and this side you have a current I2, but after some time this current again comes here and this goes to this connector. So this is the total current through the connector. Are you getting or not? So what is the current through the connector is easy. Same thing, I is equals to BLV by R equivalent, and R equivalent I know that is R plus R1 R2 divided by R1 plus R2. Are you getting or not? So this is the current through the connector, so easy one. So this is the current you have through connector. Are you getting? So this is the easy part. So one important point, you have to think about motional EMF. So in this problem, if you see, we have learned something about called motional EMF, and the value of motional EMF is BLV. So if you have a rod, and this rod is moving in a magnetic field with a velocity v, then induced EMF is BLV. Then induced EMF is BLV. Are you getting or not? So this is the thing we have learned in this problem.